All right, good evening, everybody. Welcome to another stream. I've got my Twitch to-do list up here, just as a reminder for myself. And I thought what we would do today is go back to some basic stuff. I had a few questions after the stream last week about doing some sort of 101 level stuff, and a couple suggestions or requests around some compute-based workloads, EC2. So I think that's what we're going to do tonight. You can see my 4-item to-do list. We'll see how far we make it through our list, but we want to create a custom AMI. We're going to do the custom AMI through the management console to set that up. We'll then do something that we did last week in our interface endpoint. We'll set up an instance profile. Remember that the instance profile is how we associate an IAM role with an EC2 instance. So we'll set that up, and then we're going to deploy EC2 in 2 different ways. We're going to deploy an EC2 instance through CloudFormation, and then we're going to deploy an EC2 instance, but use a launch template to do it. Launch templates are handy because we can use them. You're going to see when we'll look in the console just to show you this, but if you're deploying an EC2 instance, there are lots of options, all right, that you have to make, selections you have to make, instance size, instance type, all those kinds of things. And yeah, that you can do that, it's no problem. But what's great about a launch template is you can create sort of it's right in the name. It's a template. It's going to allow us to pre-populate a bunch of those options, and then just streamline the process of launching that EC2 instance. Whether you're launching the EC2 instance through the management console, whether you are launching that instance programmatically, CLI, SDK, or through something like CloudFormation. The other really great thing about launch templates are that you can use them as part of your auto-scaling configs as well. I think what we'll do is we'll build on top of this week, and then next week put some components in front of our EC2 based application as sort of a way to build it all out. And maybe, I know we've done it before, but maybe work on maybe a web-based workload or something like that. Okay. All right, so there's our to-do list. Before we start building out our custom AMI, actually, let's do it this way. Let's launch our EC2 instance, because that's going to take a little bit of time, right? All right, so we'll go back here, and I was deploying some of the foundation pieces and didn't make it as far as I wanted. So let me just start this one off. Actually, we need the VPC to launch this, so we'll let this finish, okay, and then we'll launch our EC2 instance. While we're waiting, I wanted to just talk about AMIs a little more. So let me go back to the iPad. And so first, AMIs. AMIs stand for Amazon Machine Images. And the way I think about an AMI is it's a starting point. It's like a gold image. Remember the old days when somebody had all the CDs and you'd pop the CD into the server and it would turn that server into something. That's essentially what an AMI is. It's a starting point. Okay, so if we start just making a few notes here. Okay, an AMI, think of it as a golden image. Oops, try that again. Right. The other thing to keep in mind with AMIs, it's a regional service. So that means that a single AMI, if we were to draw it like this, right? Here's our AMI, and let's just say it's in US East 1. Okay? That single AMI can be used to launch multiple EC2 instances, right? So what this means is a single AMI can launch multiple EC2 instances, but only in a single region. So that means in our example here, all of these EC2 instances are also in, I'll draw it, just show it like that, right? They're also in US East 1. One of the things that you do need to take into consideration, really with any workload, whether it is a EC2 based workload like we're working on in this example, or a serverless solution, is what if this were to go away, right? What if the entire region were to fail? Or what if the EC2 service in US East 1 were to fail? What do you do then? We're not going to do this. Maybe this is something we could do in a follow-up session. But you have to think about potentially copying that AMI to another AWS region, your backup region, right? So we're going to run our compute workload in US East 1, but let's say, I'll make it up, US West 1 is your secondary region, your DR region. What you could do then is you could create your custom AMI, which we'll talk about in a second, and copy that AMI to another region. And the reason that you're doing that is in the event that the service were to go away in your primary region, you could launch an EC2 instance in another region. Okay? The other thing to keep in mind is, where do AMIs come from? Where do we get these AMIs from? So I'm just finishing up the other modules. Okay, so let's talk about sources of AMIs. The first source of an AMI is AWS. Okay? So AWS provides users, us, customers, with a set of AMIs. Okay? If you're using an AMI from AWS, it's the operating system and that's it. Okay? The next option that you have, and I'm just going to show it like this, is the marketplace. If you're not familiar, the marketplace is it's basically where vendors are able to provide us with solutions that we could then deploy in our accounts, right? Like, let's say you want to run a firewall and you want to use the same firewall that you're using in your on-prem environment. You could go to the marketplace, find that vendor, subscribe to their solution, and then deploy it into your account. In my example, the vendor would provide you with an Amazon machine image, an AMI, that has the operating system and the application installed for you. Your next option is the community. Okay? You could create your own AMI and make it available to other users in AWS. Okay, so that's another option. And then finally, I will call it, how do I want to do this? We'll just call it P for private. Okay, we can create our own private AMIs, and that's what we're going to do today. And we're going to set that up with our own baked-in software, a couple packages and stuff like that, just to show you how this works. Okay, so you've got 4 sources for AMIs: AWS, the marketplace, community-provided images, and then your own private images. Remember that AMIs are regional, so you have to think about copying those AMIs to other regions. If you needed to launch an EC2 instance in another region from your AMI, or in the event that there's some sort of disaster or whatever and you want to be able to recover your EC2 instances in another region, then you need that copy of that AMI somewhere else so you could launch that instance. Okay. The other thing to think about with AMIs is what's on those AMIs. And the way I like to think about this is like this. You have a vanilla AMI. And that AMI has the operating system on it. That's it. Okay. What we then do is we install, let's use purple, we install whatever we need on top of it at boot time. When that machine comes to life, we run a configuration script on it to install everything else. Okay. Quite often you'll hear this referred to, let me just move this a touch if we grab this. Just move it here maybe. Okay. A lot of times you'll hear this process. Let's use this color. This process I know I broke that into 2 words and it's not 2 words, but it's called bootstrapping. When the machine comes to life, by bootstrapping it, Once the EC2 instance launches, then you run a configuration script to install everything else. Okay, so that's your first option. You've got your vanilla AMI. The next type of AMI, the way I think about it, is we have what I call a half-baked AMI, which has our operating system and maybe some, I'll just call it base here, some base components. This is what we're going to do today. Okay, the base components in our example will be things like the SSM agent, the Unified CloudWatch Log agent. We're going to set all those up. And then you may bootstrap that machine with anything else, your application components. Maybe if you're building a web server, when the machine comes to life, you copy the source files down from S3 and they get copied into a working folder or something like that. Okay. And then the final type of AMI that I like to think about is what I call a fully baked AMI. So you can see where this is going, right? And we'll show it like this. You've got the operating system, the base components like agents and things like that, any software that is going to be there, and then the application on top of it. How do you decide which path to go? It's going to be totally up to you. I kind of like the half-baked image in the middle here, because it gives us the way I like to think about it is, these types of components, the base components, the agents that you need, the versions of those agents might not change very frequently, those kinds of things. So if I can bake those into the image, that means the image can come to life faster because there's less for me to load on the image at start time, right? Versus components that are changing more frequently, maybe the application components or something like that, then I can install those at boot, right? Fire those up and run a script or whatever. Okay. So that's our kind of the different types of AMIs. And as I mentioned, we're going to kind of work on an example there of a half-baked AMI. Okay. Let's flip back to the console. And we've got our VPC. So what I did was I created some basic IAM resources. I'll show you these in a second. We created our network. We enabled flow logs within that network. And we created a security group that we need. We're going to need a security group to launch our EC2 instance. So I just built a simple one. And we'll go through these. If you watched last week, these will be familiar because I'm borrowing from the work we did last week. I'm pulling that into this week's templates, just so we didn't have to build everything from scratch. Okay, so if we go to the EC2 console, you can see we've got a couple components here deployed already. Actually, let's do some cleanup. This must have been from a demo I was doing. Yeah, ran a class last week. Let's clean these out just so it's less confusing. And then what else did I see there? I think we had some snapshots too, so let's just, those might be from AMIs. Yeah, see, I've got a couple AMIs in here already as part of the class. So let's clean those up. My cleanup script didn't work very well. Okay, these should go away because they're part of, so this was created through the image. So let's go, and we're going to go over to instance, and we are going to create a new instance. And I like to call it my AMI builder. Okay, so this is the machine that I'll use to build an AMI. Let me zoom in a bit. Okay, so we'll just call it AMI. And you can see here, these are the quick start AMIs that are available to us from Amazon. And you'll notice here, you can you can browse AMIs from AWS, the marketplace, community, and then you could also use your own if you'd like. We don't have our own yet. I'm going to use Amazon Linux. I'm going to use the newest version of Amazon Linux 2023, and I'm going to use an ARM processor, so we can use Graviton chips. And then for what we're going to do today, we'll just do a T4G small. Okay. Key pairs. If you're not familiar, a key pair is the public-private key combination that you can use to log into this machine in this case our AWS Linux machine, using the built-in privileged user. You'll notice here that in the EC2 console it says proceed without a key pair, not recommended. But if you look at some of the newer recommendations that you might see in Security Hub, it'll actually recommend that you don't launch EC2 instances with key pairs on them. Again, this is going to be a decision that you have to make. I generally go down this path. Instead of installing key pairs and then having to manage those key pairs, right? Store them somewhere secure, because if you lose them, you can't get them back. Make sure that only the right people have access to them. Trying to enforce the fact that if somebody logs in as an EC2 user and does something, you don't actually know who that was, right? Because it's just a generic user. I like to instead add our EC2 instances to a directory service, an LDAP server, an AD server, something like that, and then use the credentials through that directory service as the way that you provide access. We're not going to do that today. Instead, we're going to use SSM to get access to the machine. You know, it's the same thing. It's a shared user, but it allows us to avoid having to use things like bastion hosts where we're tunneling through one machine to get to another one. This way I can access this machine without it being directly accessible on the public internet. Okay? And it also helps us avoid having to deploy an EC2 key pair. So we're going to do this. And then I'm going to go here and I'm going to say edit my VPC. And yeah, this is fine. It's going to put it in one of the private subnets. And we are going to use an existing security group. So this is the security group that I deployed already. And it's just called demo. We've got a bunch of options, choices to make on the storage side. When you use a newer instance type, like we are, the ARM processors, Graviton-based processors, then it should default to GP3, which is the general purpose third generation of SSD drives. So we'll leave it that. And if I go under advanced, I want to show you something. I think we talked about this last week. Your last line of defense is encryption. So make sure that you protect all of your data both at rest and in transit using encryption. And you'll notice that this is encrypted by default. How did we get this set up? If I go back to the EC2 console, over on the right-hand side, you can see a bunch of settings here, right? And what we can do is just go data protection and security, and right here is default EBS encryption. This is disabled by default, unless Amazon has changed something, which I don't think they have, okay? That means that when you deploy an EBS volume, by default, it will be unencrypted. I would suggest that you enable default encryption. And we are using the default encryption key. So this is a key that is in the key management service, KMS, and it's managed on our behalf, okay? You can use your own customer managed key. And if we're building this out for a customer, we would definitely use a customer managed key, not the built-in one. But to demonstrate this for today, we'll just use the built-in key. Okay? So it's up to you to decide how you want to tackle this. But what's great about this is it makes sure anytime somebody launches an EBS volume, you can be guaranteed that it has encryption at rest because it will always use that default encryption key. Okay? What if you have an existing account and you have been building out things and you realize, oops, I don't have encryption enabled? If you enable default encryption now, going forward, any of those new EBS volumes will be encrypted, but the existing ones will not. Okay, it doesn't change anything. Hey, Kevin, welcome to the stream. Okay, so that's what we've got here. We won't add any additional volumes or anything, at least in this little demo, but you could add anything you would like. Okay, there is a physical limit to the number of EBS volumes you can associate to an EC2 instance, a single EC2 instance. I can't remember if it's a physical number limit or a total size. You can look that up in the documentation, actually. Let me find it and I'll just share it. Let's see here. Yeah, this is what I was looking or thinking about here. I'll throw this in chat so you've got it. Okay, so that's the link to all the documentation about EBS volumes. And if you go to that page, actually, let me pull it up. Okay, so you'll notice if you use GP3 or GP2, you can have a single volume up to 16 terabytes in size. And then there is a limit to the number of volumes you can associate with a single instance. I don't know if it says it here on this page or not. Doesn't look like it does. You could dig around a little bit and find that. Okay. So we'll leave this alone. Under advanced details, as I was mentioning as we got the stream started here, you can see there's lots of choices to make, right? So we're going to do a couple really basic things, and if you've watched the stream, you know what's going to happen here. I'm going to associate this with an instance profile, and the default instance profile that we use for everything that we create at least gives us access to the SSM service. That's always handy. And then the other thing we're going to do, and again, if you watch the stream, you know where I'm going here, is metadata, and we're going to require version 2 of metadata. For those of you that aren't familiar with this, metadata provides us with configuration information, the current configuration information about that EC2 instance. There's 2 versions, version 1 and version 2. Version 2 is more secure because we have to pass a token. So version 2 is the recommended implementation of metadata. If you don't use version 2 and you have something like Security Hub running in your account, it's going to flag that as a non-compliant deployment. Okay, so turn on metadata version 2. And then finally down at the bottom, a user data script. I mentioned as we got the stream started, remember we were talking about, if I go back here, right? And I was just talking about this idea of bootstrapping. One of the simplest ways to bootstrap a machine is with a user data script. So in this user data script, I could run something as an example, really silly example, but I could do something like this. Right, I could just run a yum update command the first time it comes to life. Thing to keep in mind with user data scripts like this, by default, a user data script runs only the first time a machine boots. Okay, if you stop and start a machine, the user data script doesn't run again. Okay, but if I create my AMI and I launch a dozen EC2 instances off of that AMI, the first time each of those EC2 instances boots, it will run this user data script. You can override that and have it run again if you'd like, but the default is run a single time. Okay, so then we're going to launch our instance. All right, so that's that. And then if we go back to view instances, it's coming to life. Give this just a minute. Let's see if we can log into it already. Not quite yet. Oh, there we go. Okay. So again, pretty standard operating for our stream here. Zoom this in just a touch more. Right, we're on the internet. We don't have any patching to do. And if you're looking for, if you've got a user data script in place and maybe you log into the machine and something you expected to be there isn't there, go to, I have to be root to get to this directory, so I'll just do sudo. Right. Here's another thing, let's get bash going. If you go to var log, under var log, you've got these 2 files here, cloud init and cloud init output. This is the logs from the user data script. So I could just do something like this. Right, and there's the output. You can see right here, this is where, I think if I read this properly, I'll show you in the other file too. This is where we ran our, it looks like it's trying to patch here. So this would have been the output from our, what's it called? Our yum script. Although it's weird. No, this isn't our yum script. See this address here, 169.254, 169.254. That is the ID that's used for metadata. Okay, let me show you what I was expecting to see here. I'm not sure what that is. We won't get too hung up on it. Where is it? It's a lot of stuff in here. Let's try this again. Cat. I'll do the output. I think it's in output. It's easier to read. There it is, right? So you can see it booting up, generating its key. And yeah, right here, this is where we ran the yum update, and it basically said there's nothing to install. Okay? So those are the files that are interesting if you want to check the output from your user data scripts if something didn't happen the way you would expect it to happen. Okay? So right now we have, this is an example of what I called earlier a vanilla AMI, right? All it has on it at this point is an operating system. That's it. There's nothing else. What we want to do is we don't want to bootstrap this machine from scratch every time. So we're going to create a half-baked AMI. And really all I'm going to do today, just as a demonstration, is install a few base components. These are components that I want to make sure are in every EC2 instance I launch. So SSM agent in the past would have been one of those, but it's pre-installed now on the operating system we're running. What I'm going to do is I'm going to create, or we're going to install the CloudWatch log agent, and we're also going to install some utilities that we might use in a future stream for EFS. Okay? And then that way we've got those agents and those tools installed for us and ready to go. And we're going to do this in a couple different ways. The first thing we're going to do is we're going to go over to SSM, and I'm going to use the run command to install the unified CloudWatch log agent. Okay, and we're going to say run, and we're going to say, I think it's configure AWS package, and then this is just, I'm hoping I can remember this, CloudWatch agent. I think it's like that. It'll complain, and if it's the wrong package name, I'll have to Google it, but I'm hoping this is right. And then we can just choose our instances manually for now. This is our AMI builder, and we'll say run. Let's see if I got the package name correct. Well, it didn't error immediately. There we go. Okay, so now the unified CloudWatch log agent is installed. The next thing we need to do is configure that agent. If you remember, what we did is if we go back here, we go to EC2, we highlight this guy. This is the role that we created. Okay. And remember, you associate the role with the EC2 instance using what's called an instance profile. And all it has right now is SSM managed instance core access, and oh, this is leftover. Let's do a couple things. This isn't great because we don't need this. So if we want to practice least privilege, this isn't a good idea. So let's clean this up first. Okay, so let's go over to PyCharm. Oh, I was on the wrong screen that whole time. Okay, hold on a second. I'm still not used to this new setup here. It keeps messing me up. Well, all I was showing you really was that I've got permissions on this EC2 instance that we don't need. So let's remove those. So if we go back to PyCharm, like I should have done, we go here, we go security, and then all we're going to do is we're going to remove this EC2 managed policy. Okay? This is giving us that extra access. Illustration was good. Thanks, Kevin. All right, I didn't realize I was on the wrong spot. So that's good. That's really all we need to do. So let's do this, and we'll just say fix removed unnecessary permissions from EC2. Let's deploy that. And you know, one other thing I meant to do before the stream started and I forgot. Let's make this a little bigger. Not 1800. Let's see what that looks like. Didn't really change much, did it? We'll make it 22 for the stream. That's pretty good. That's easier to read, eh? Okay, great. Now, if we go over here, let me just check where I am before I start sharing my screen. Give me a sec. Yeah, I want to make sure I'm in the right project. Perfect. Yeah, we are. So you can see here our pipeline ran, and this is just to remove those additional permissions that we don't need. So we will go back here to CloudFormation, and here's our demo IAM, and we've got our change set, and we're removing that policy. So we're going to execute that. Now, one of the really cool features of the Unified CloudWatch log agent is we're going to run the configuration script on our EC2 instance, but instead of storing that configuration, basically it creates a JSON document for us, right? Instead of storing that on the local machine, on the EC2 instance itself, we're going to store that in the parameter store in SSM. Why is that important? That means going forward, any other EC2 instance that we bring to life, assuming it's a Linux machine, right? What we could do is we could boot that machine up, and it would be able to take the configuration file from the parameter store in SSM and boot itself up and have the configuration that we want. Okay. To do that, though, we do need to add some additional permissions just temporarily to our EC2 instance. So we're going to do that by going back over here. And you'll notice we just have the single policy now, right? What we're going to do is we're going to attach another policy, and this is another AWS managed policy. And if we just search for CloudWatch, maybe, see this one right here? There's CloudWatch admin policy and CloudWatch agent server policy. This is what we want. See here, it gives, if I just change the size of this, full permissions required to use the CloudWatch agent. And if I look at the permissions associated with this, it's a little small again, isn't it? Yeah, this tab's not zoomed in. Okay, so we're under the CloudWatch agent admin policy. It has the ability to both get and put parameters in the parameter store, as long as the parameter we're storing is prefaced with Amazon CloudWatch dash something. So we're going to assign this policy temporarily. Once we're done, though, with the first configuration, we're going to use this policy instead. You'll notice the only difference is now the EC2 instance here doesn't have the ability to put parameters, but it can get the parameters that it needs to configure the CloudWatch log agent. Okay. We're going to do this manually here to get this set up. Now my screen's so big I can't find the stuff. Add permissions. So we have the two permissions, okay? I have to look this up. I always forget. I'll share the link to this. I can never remember. AWS Unified CloudWatch Agent. Let's try Configuration Wizard and see if Google drops us in the right spot. Yeah, okay. This is what we're after. So let me share this in chat. And then I'll dump it into a tab over here, and I'll show you what we're going to do. Okay, so we're going to use the configuration wizard to set up our agent config file. Okay, and you'll notice it needs credentials. We are not setting up access keys. Please do not set up access keys on your EC2 instances. Right? Remember, access keys are permanent credentials. There's no built-in mechanism to auto-rotate them. When we audit AWS accounts for customers, 9 times out of 10, there are very old access keys. Don't use them unless you have no choice. The way that we're avoiding using access keys in this example is a role, right? We've assigned a role to our EC2 instance, which then will be assumed by the application to give it temporary access to another service. In this example, that other service is the CloudWatch logs service. Okay, so that's what this is. And then there's a bunch of predefined metrics. I shared this link already. Yeah, so you can dig through these and have a look at them. Down, if you continue to scroll, you get to the bottom. This is what we're after. Configuration script for Linux, configuration script for Unix. So we're going to, that was weird. Configuration script for Linux, configuration script for Windows. I think I said Unix. So copy this, go back to our systems manager window. Let's just clear this off and run. Now we just have to follow the instructions. Easy, right? What operating system? It's all preset for us. So it's Linux. It's an EC2 instance. We're going to run the agent as the root user. Do we want to turn on statsd? Yes. What port? What's the interval? We're going to use all the defaults for this. So we're going to say every 10 seconds. And then what's our aggregation period? That defaults to 60 seconds. So that's fine. And here's one thing you have to be careful of. Do you want to monitor metrics from CollectD? Warning, CollectD must be installed or the agent will fail. And you'll notice that it says default is yes. So we're going to change this to 2. We're not going to set up CollectD. Okay. Do we want to monitor any host metrics? Yep. What happens here is what's also great about the unified CloudWatch log agent is it allows us to gather up log data. So operating system logs, application logs, any custom logs that we might have installed on this machine that we want to get out or off of the EC2 instance and into AWS. That's what this agent does. But in addition to that, it will collect additional metric data for us. By default, CloudWatch doesn't collect memory utilization. It doesn't collect logical disk space. We can set this up so we'll get that metric data, right? People that are running EC2-based workloads want to know memory utilization. They want to know logical disk space. That's why this agent is so important. So we're going to say, yep, we want to collect that. And again, do you want to monitor CPU metrics per core? Sure. Do you want to add dimensions, blah, 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 into those metrics? Yes, we do. Do we want to aggregate those? Yep. And how often do we want to collect those metrics? Every 60 seconds is fine. And then this here, which metrics package do you want? Basic, standard, advanced, or none? If you flip back to this page, right, it shows you on-prem Windows servers, EC2 instances running Windows, on-prem Linux, and then here's us. So I think for today, we'll use standard, which would give us disk usage, memory usage, and swap space. Okay. And then you can see if we go down into advanced, we get some additional things like network monitoring and stuff like that, but we don't need that for today. So we will say standard. Okay. Here's the config file, just a JSON document that describes those choices that we made. Are we satisfied? Sure. Do we have any existing CloudWatch agent config files to import? No. Do we want to monitor log files? This is that idea of the unified agent, right? Additional metrics and log data. So we're going to say yes. And for today, I think all we'll do is we'll set up monitoring of our operating system log. I think it's just var log messages, which now I can't remember. So let's do this. I think it's just var log messages we'll grab as an example. So we're just going to open up another session here. Hang on one sec. Hey, yeah, that Kevin, thank you for the comment. I know I'm trying to figure out. I haven't had enough time to kind of lay the screen out the way I want. The new piece of software I'm using, I think, is almost overkill for what I'm doing. There's a lot of customization I can do, and I can't get the ratio of the screens themselves correct. It's weird. I can't figure it out, but it's bugging me. So I'll figure it out. Thanks for the heads up. I appreciate it. And yeah, rage, right? I can't get it working myself. Maybe one day I'll do a stream on setting up the stream and I can just sit and fiddle around with getting everything properly set up. It's the tool is really feature rich, and which is handy, but also annoying. All right, so this is what we want. We want, oh yeah, see, this is Amazon Linux 2023, so the names have changed. I think we just want, if we do sudo cat dnf log, yeah, that'll do. This is kind of like the system log, right? It's basically showing what it's doing. Okay, so we'll grab that. Is there anything else that's interesting? Well, I guess we could do the cloud inits, but we'll keep it simple today. So we're just var log dnf log. What's under Amazon? Oh, Amazon will have here our CloudWatch agents, okay, and the SSM agent, but we won't worry about that. So we're going to just do this /var /log dnf log. And then what's our log group name? And this will just pick up the file name. So I think what we're going to do is we're going to call this instead, we're going to call it OS log. Okay. And then what's our stream name? Inside that, now our log group called OS log will have a stream name that's organized by instance IDs. That's fine. And then what's our retention period on the log groups? Remember that by default log groups will retain data indefinitely. I don't know if I gave it enough permissions to do this. Let's see what happens. We'll set it to 13, which is actually 365 days. So we'll hit enter. Do we have any other log files we want to monitor? We'll just leave it as the one. And do we want, ooh, this, I haven't seen this before. Do you want the CloudWatch agent to also retrieve X-ray traces? I'm going to say no, because I don't know if I have the permissions to actually do this. Like I said, I haven't seen this before. If you're not familiar, X-ray is a service that you can enable, originally released for Lambda, that will give us trace data. So every client request will get a trace, which is broken down into segments, and you get a visual representation on what's called a service map of all those requests end to end. We don't really need it for what we're doing, so I think just to hopefully get this to work, we'll say no. And do we want to store the config in SSM? And this is why we added those permissions, so I'm going to say yes. And then we'll give it a name. And I think for today, we'll just use the default, right? Amazon CloudWatch -Linux. This could be something more appropriate. Like I'm thinking about a project we did. We called it Amazon CloudWatch Apache. And that was the SSM config file that we could use on all of our Apache servers. But this should do the trick. Where do we want to store that? Which region? CA Central 1. These are the credentials that are coming from the role. There we go. Perfect. Now, if we go back here, if we go to SSM, we go to the parameter store, you can see I've got some demo stuff in here, but this is the new file that we just created. So we took that JSON file from the EC2 instance and dumped it into the SSM parameter store. And now all we need to do is we can go back here to Systems Manager to run command, and then we can run another command. And we got to flip through a bunch of pages here. We're looking for, I'll know it when I see it. Lots of built-in run commands. This one right here, Amazon CloudWatch Manage Agent. So we're going to select that. And then what we're going to do is we're going to say Amazon CloudWatch-Linux. So this is the name of the config file in the parameter store. I don't even know if we need to do this, to be honest. This is just a habit I started. I don't know why I did this, but now I just kind of always do it. I'm going to make sure that the agent is running and using this config file. Okay, so we can just go down here and say run. Perfect. Now, one other thing I want to show you. Back on this documentation, troubleshooting the CloudWatch agent and verify that it's running. You can do this with the run command, but we're going to jump onto the Linux server and we're going to go like this. it's running. So we should be good. What should happen at this point, and it might take a little bit of time, is if we go here, we go to CloudWatch. And then we go, metrics, sorry. I'll show you a couple things. So if we go under metrics, am I in the right region? I'm not. Go here. This might take a bit of time to show up. What we should have here is a new grouping for metrics, which would include our SSM agent info. And then on top of that, we'll have at some point a log group. What did I call it? OS log. See, this is what I was thinking about. See the retention period? It's set to never expire, even though I said 13 days, or sorry, 365 days. There's an additional bit of permissions that we didn't add. And if we go look at CloudTrail, we'd see an error message there. Permissions denied, permission denied, right? But what should happen for now, there's the log stream organizing our records by instance ID. And then if we go in here, these are all the logs that were in the DNF log. Okay, these are all the entries. So that's working, which means our agent is running. It just hasn't collected any metric data yet. So we'll let it run for a little longer and see if it comes to life. Okay. The other thing I wanted to do, again, just to kind of demonstrate this idea, is EFS utilities, because maybe we'll do this later. If we wanted to, let me just make sure this is the right page. Yeah, this is it. Here, I'll put this in chat as well. Okay, so just to, again, to demonstrate this. This is our Amazon EFS utilities package. Just makes it easier to talk to EFS. And we can go here. And it's just a single command, this one. And we'll go back to our EC2 instance and run this as well. Okay, so we're just installing that EFS tools. Now, this is that idea. If we flip back here, kind of what I'm trying to demonstrate is this. We now have a half-baked AMI. We use the operating system provided to us through the Amazon AMI, and then we installed our base packages, our CloudWatch agent, our EFS tools, and then in theory we could finish the configuration when we boot this machine by running a configuration script, right, to install maybe the application components or something like that. Okay. So this is kind of at least a way to demonstrate this idea of a half-baked AMI. Once you've installed everything that you need, okay, what you could then do is you go back over to your EC2 console. Let's close a couple of these windows down. Okay, we can go here, and you don't need to do this, but again, I kind of do it. Old habits. We're going to stop our instance. There it is. Give it a second to stop. All I'm going to do is I'm going to create a machine image. And at that point, while I'm waiting for this, what we've really done is we've done this. We've created our own private AMI, which we could then use to launch a fleet of EC2 instances in the region where that AMI exists. Okay. Did it stop? Always when you're waiting for it, it takes forever. Come on. Oh, there we go. So now we're going to go here and we're going to say image, create image, and we'll just call this Twitch demo. And today is what? Wow, October 31st. So I'll just date stamp it, and that way we can, if we ever create something later on, we can tell the difference. And we'll say create. Okay. So all that's going to happen now is it's going to go off and create that AMI for us. And remember, the AMI is the starting point for the rest of the work that we wanted to do today. So if we think about, if we use our handy little check marks, we created a custom AMI. Okay, we simulated that sort of idea of a half-baked AMI. We've already created that instance profile, although we do have to make a small change. So let's go make that change now before we move on. And the change that we need to make here is in our permissions. Because, actually, let's do it this way. We'll go back to Firefox first. We'll find this, we'll go to the role, and we need to remove that admin policy that we added temporarily, this one. Okay, so we'll remove that. And then I'm going to say add permissions. I'm not actually going to do this, but I'm going to go AWS managed, CloudWatch agent, and what I want is this one. Because remember, I mentioned already, it reduces the permissions it has, right? All it can do is run gets. And what I need to do is just get this. So we're going to copy this. We're going to go back to PyCharm. And we are going to go here and add it. So now we're going to use 2 AWS managed policies as part of our instance profile. One provides us with the managed, the minimum requirements for SSM, and the other allows the CloudWatch agent, excuse me, the unified CloudWatch log agent, the ability to get the parameters from the parameter store. That's all we need to do. Right, and we'll push that as well. Okay. Go back here. There we go. That should happen pretty quickly. At this point, it's a pretty basic pipeline. Oh, IAM is done, which is the one we're interested in. So we should be able to go here now. Oops, got logged out. Hang on one second. Don't be back there for a sec. Okay. So, yeah, we got to go here and find our demo IAM, and we've got a change set so we can execute that. And all that's going to do is add that additional permission. So that should happen pretty quickly. We can click on resources and go to that demo IAM role. Maybe we can go to the demo IAM role. Try it again. We'll go right to the IAM console. There we go. And we'll just do demo. Here it is. And now we've got the 2 AWS managed policies that we need. Okay, perfect. So that's done. So that means if we go back here, now we've got a true green check mark on number 2. So now let's build out a CloudFormation template to deploy our EC2 image, or our, sorry, an EC2 in. Let's try this again. Let's create a CloudFormation template that allows us to deploy an EC2 instance based off of that custom AMI that we created. So step number 3. So we'll go over here, and I cheated a little bit. It's like a cooking show, right? What I did was I at least dumped these here, okay, placeholders, so I kind of jog my memory on what I needed to do. I'm just going to copy this like we always do, maybe. and we'll do this. Why do I have two YAML files under our compute section? Because I want to just demonstrate the difference between using not using a launch template as part of your deployment and then creating a launch template. So we'll say create EC2 resources for our Twitch session. We can leave this alone, and then like we always do, we'll just clean this out, use it as placeholders. All right, let me find the doc for CloudFormation and EC2. Okay, this is what I'm looking at, and then we'll pull it up into Firefox. And like I mentioned already, there are lots and lots of options. Obviously, not all of these are required. We're not going to use all of these today. We're just going to use a small subset of them to demonstrate how this works. But if you did want to build out this EC2 instance, then obviously it's important for you to understand what these different properties are and what you need to use as part of your deployment. Okay, so let's flip back over to PyCharm. And I'll keep another window with the documentation open. Okay. So we're just going to call this EC2 no LT for no launch template. Okay. And I'm going to read through. We're going to look at each of the options here in the configuration file and decide what we need to do. One of the things that I will do is I know in our AMI we didn't add additional devices, we didn't add additional block storage. If you wanted to add additional block storage in CloudFormation, what you're going to call that is a block device mappings. Okay, so let's set up something like this so you have an idea of what to expect. And let me just pull this up in the doc again. Okay. This is not required. It's just an extra step we're doing to show you how this works. Okay. So our device name in this case will be /dev, and let's go back here for 1 second. I always forget what the default one is, the root volume. So if we go EC2 instance, oh, sorry, I didn't restart it after. Do we have our AMI? Yeah, okay, so that's there. Let's just restart this instance. Under storage, so XVDA is our root volume, okay, and then we can add additional volumes if we would like. Okay, so we're going to go back over to PyCharm, and we're going to say XVDA. So this is our root volume, and then we need to give it some EBS parameters. We're going to say delete on termination is true. Encrypted is true. What's our KMS key ID? We are going to pass this in, and we're going to call it default EBS key ID. Okay, remember that was the setup piece that we had earlier on, so we'll use that. Volume size, we're going to do ref root volume size, and then we're going to say volume type is ref. We'll separate these, so we'll say volume type. Okay, so that's the first one. And then we're going to do this, and we'll make this, let me just check. I can't remember where it starts. VDA is the default. That's our root volume. Let me just check where this is. guess as long as it's not A. I'm going to use the example in the doc. We'll just make it H, okay? We're going to change this to false. So our root volume gets deleted on termination. You could consider this, you could call this your data volume. It is not deleted on termination. And we'll call this data volume, okay? Because what we can also do here is mix and match the different volume types if we would like as well. So let's grab these and we'll put them up here. Okay, so let's say type, what is this? I would assume, I'm gonna say it's a string, but I'm not 100% sure. Oh, it's actually an integer, okay. So this is a number, and we'll just say the default is, we use the same default, 8, okay? And then the other one is root volume type. We'll say type is a string, default is GP3, and then we'll set this up, we'll say, oh, I typed GP2 and said GP3. We'll just use the two general purpose SSD volume types for now, but you've got magnetic and you've got some hard disk drives you could use as well. You've got provisioned IOPS drives you could use as well. And we'll just keep it like this for today. We're going to copy this and we'll just say data volume, and let's make our data volume bigger than our root volume just to show the difference between the two. Okay, so that's what this is. Hopefully, fingers crossed. I always mess this one up, so oh, you know what we didn't do? We didn't put this in. So let's put this right here, and we'll just say type string. We won't hard code that as a parameter here. We're going to pass that in as a parameter override when we run our CloudFormation template. All right, so those are the first couple things. Let me continue to read my list here. And again, just so you're clear, all I'm doing is I'm going through this list, just working from the top down. Okay, most of this we won't worry about for today. We'll just make sure we get the required stuff. Okay, so the next thing that we need is an IAM instance profile. And I'm just going to do what we normally do. I'm going to say a bunch of to-dos, right? We'll get all our placeholders set up. We need an image ID. This is where we're going to refer to our AMI ID. We need an instance type. It's a small, medium, large. Okay, we'll put our placeholder there. We're not going to use a key name, so we'll leave that blank. We're not going to use a launch template in this example. There's things like EBS optimization and enhanced monitoring and things like that. We won't worry about that in the demo today, but you can turn those on if you'd like. We need a security group, at least one. So we'll do this. And then we need a subnet ID. You know where this is going. There. And I think then we can use tags, which we will borrow from over here. I think we have tags somewhere already, don't we? Yeah. Just use the same tags. Okay. So let's fill in these. Our instance profile ID. We can grab this from our IAM stack. So we'll do what we always do, and we'll put placeholders here. All right. I'll find that import command that I can never remember in a minute, but that's our first one. The image ID, that can come from here. So we're just going to say, oh, wait, no, let's, I'll come back to image ID. We're going to do this. Our instance type. So this is going to be a string. Our default will be T4G small. And then just like we did in the earlier example, we'll say T4G nano, T4G small, T4G, I don't know, medium. Obviously you could make that list as big or as small as you'd like. That's up to you. But this will help, this will do enough for today. So we're just going to say here ref that. This gets pulled from, let's do this. Let's just put a placeholder here, stack references. So we need the VPC stack. We're going to pull that in for our subnet that we need. And then we need an SG stack. Okay. And now let's go find, that'll take care of this one, and this one, and we'll come back to the image ID. I'm pretty sure I have an import statement here somewhere. Yeah, this is what we want. Okay. So we'll grab this. This will be, oh, that'll be IAM stack. We'll have to change something else. We're gonna say, oops, grab this. Actually, let's do them one at a time, otherwise I'm gonna confuse myself. So down here, ooh, let me just check something. I always forget. Instance profile. Does it want an ARN or the name? It's the name. Okay, so then we want this value, right? So we'll go here and just paste that there, and then we'll just copy this again, and let's do our security group. So this will be SG stack, and we'll do the same thing. Go over here, and it's just EC2 ID. We only have a single security group at this point, and then this will be VPC stack. By now, you'd think I'd remember what that output value is, but I do not. We're going to put it in one of the private subnets, so we'll put it in private subnet 0. Okay, oops. All right, perfect. The only thing that's left for us to fill out now is the image ID. And remember what I was saying is that AMIs are regional services. An AMI is bound to a particular region, and within that region, we can launch multiple EC2 instances using that same AMI. We could go in here and hard code this, right? Like that. But we want to make these CloudFormation templates as flexible as possible, meaning that, you know, Kevin, I'll use you as the example. I give this template to you. I don't know what region you're going to launch this in. So what we want to do is we want that image ID to be dynamic, so that whatever region you launch this in, it'll pick the appropriate AMI. How do we do that? We use another section in CloudFormation called mappings. So we're going to do this, mappings, and I have to look this up. I can never remember the structure, so give me a second. And I will share the doc page. Okay, there you go, maybe. Oh, yeah, there we go. Okay. And I want to just get the YAML structure. So we need, we'll call it AMI map. That's our logical ID for the map itself. Then we're going to say CA central 1, and we'll call this Twitch. And here we want to get the machine image from our AMI. So if we go back over here, we go to AMIs, all we want is this. Okay. And then if we go back to PyCharm, we can do this. And then let's go like this. Okay. And you can imagine, what if you had a bunch of different applications? So you could say, right? See what I mean? And then you could just refer to, I need the Twitch machine, I need the web server, I need whatever, and you've got all the AMIs for each of your regions. For us, we just have the one. Okay. Now, how do I get this AMI into this region so I have an AMI ID to use? A couple ways to do that. Okay. For today, what we'll do is I will show you the quick and easy way to do it. I'm just going to copy that so it's got its name defined. Okay, I'm going to go up to Actions. I'm going to say Copy AMI. Okay, where do I want to copy this to? US East 1, and copy. as is the case with everything we do in AWS. Management console is one option. You've got programmatic access, so we could run a CLI command to do this. If I was building this for real, and I think we did this a long time ago, is AWS has a service called Image Builder. And remember that an EC2 instance is an example of an infrastructure as a service offering. Okay? Remember the shared responsibility model. I will share that. It's probably one of the most, it's a really easy document to understand. It's a really important document, but I can tell you that it's a document that's often overlooked. So if we look at this, let me zoom in here. This one's too small. Okay. This is the shared responsibility model. AWS is responsible for the security of the cloud. The customer, us, we're responsible for security in the cloud, which includes the operating system. When we're thinking about EC2 instances, it includes the operating system and everything above it. Okay. This AMI that we've deployed as an example, it's our responsibility to maintain the operating system on that EC2 instance. You have to patch it. What we've got now is a situation. How do we do that? We've got EC2 instances running from that AMI. Well, the AMI is just like that CD, right? That gold image CD. We're not using it anywhere. It's like, you know what I mean? It's just sitting there. It's an image. So I could use Patch Manager as part of Systems Manager to maintain the running operating systems. Run patching every Saturday afternoon or something if you wanted to do it that way. But then the question is, how do I manage the image itself, the AMI? And that's where this service comes in, the Image Builder. So if we are working with customers that have fleets of EC2 instances, right? And I know serverless is all the thing, great. Obviously serverless is important for a bunch of reasons. However, what I'll say is in real life, we got a lot of customers that are running EC2 based applications, okay? How do you maintain those AMIs? You could build something from scratch if you wanted. My suggestion is to check out the Image Builder. What we can do now is create a pipeline. And I'm thinking of a particular example for a customer. We've created a pipeline. Every Saturday morning, we create an EC2 instance from that AMI. We patch that EC2 instance. Right? We run a yum update on it as an example. We create a new AMI, and then we copy that AMI, in their case, to 3 regions. Their primary region, their secondary region, and what they call their zombie region. If something really, really goes wrong, I've got a third copy of that machine that I could go back and get. Okay? So we maintain those AMIs on a weekly basis, and as part of the Image Builder process, we can distribute. I never say that word right. My wife laughs at me every time she hears me say it. We can distribute, still doesn't sound right in my head. Let's say we can copy those AMIs as part of the workflow to multiple regions. We just did it manually, but you don't want to do this. You don't want to have to remember every Sunday morning, oh, it's 10 a.m., I got to go and do that work. And the beauty of this platform is that it's really it's essentially a collection of APIs. And because it's just a collection of APIs, we can automate the heck out of it. So why do it yourself when we can do this? Okay. Same rule goes with Systems Manager. If you've got those long running EC2 instances, again, in real life, you see it all the time. Use Systems Manager in AWS to patch the running operating systems, keep those up to date, and then use Image Builder to maintain the AMIs so the next time I have to launch a new instance from that AMI, it's been patched already, right? It's got the latest operating system patches, whatever you need, so you launch your machine and then bootstrap it, you dump your application on top of it. Okay? So that's the Image Builder. And with that, I've completely forgotten where we were. Oh, yeah. Okay, so what I wanted to do is I copied that AMI just to show you we could do something like this. We go to US East 1 now. Here's our Twitch demo again. Okay, and we'll copy this AMI. We'll go back to PyCharm, and we'll dump that here. Okay. Again, you could see how, depending on what your requirements are, you could have 2 regions, you could have 10 regions in here, depending on the level of flexibility that you want or require based on what it is you're trying to accomplish. For our demo today, this is more than adequate. And then how do we refer to this? We use an intrinsic function. It's called find in map. So we're going to do find in map, and there is a structure for this that I never remember, so bear with me a sec. And I will share this as well. All right, that's what I'm looking at, and we'll just filter this down to YAML, and we need the map name, which I already forget. We called it AMI map. Okay, our top level key is our region. So we're going to use a pseudo parameter for this. We're going to say, whoops, we're going to say ref AWS region. So this will pull in our region, which I'm going to check the formatting on that. Can't remember if I need single quotes there or not. Okay, and then we need our second level, and in our example it's just going to be Twitch. Okay, let me check this pseudo parameter. Bear with me one sec. And I'll share these as well, so you've got the list of them. These are handy. I just want to find, what did I use region? Doesn't give you a lot of great examples. Do they give us an example at all in this documentation? Okay, they do have it in quotes. I'm going to leave it like this. What's the worst that can happen? So now we've got all of this populated, right? And we need an output. So let's do, oh, one other thing we need. We need a key name and then a value. So I'm going to hard code this, but you hear me say this all the time. If we were building this for a customer, we would use, again, intrinsic functions, like sub things in, make it dynamic. But to demonstrate this today, EC2 no launch template. Okay, it'll work. And let me just find the outputs for EC2. We won't do them all, but we'll just do something like EC2 no LT ID. So type, or sorry, value is ref EC2 no LT. Export is sub, and we always do this one, so we'll say AWS stack name dash EC2. Let's just do ID. Okay, perfect. So let's add this to here. We'll run our simple validate script, modules, compute, EC2, and then we'll jump over here, and I'm just going to copy this. And we'll say EC2 no LT. No LT. And we'll call this no LT EC2. And we need in this IAM stack, they're all going to be named basically the same thing like this. SG stack is demo SG, and then we can run a couple overrides down here. Right? Did we need anything else? I think we hard-coded everything. Like, we have default values for all of this stuff. Yeah, I think that should be good. IAM, VPC, SG, these all have default values, and we have no to-dos left. Okay, so let's try this. I got logged out of GitLab. Just bear with me a sec here. I'll dump you back onto the iPad screen for a sec. think when I closed all those windows, when we got logged out, I think I actually closed the windows on ourselves, or closed the window on ourselves. Okay, so we got a typo or something here. Imagine that. YAML not well formed, line 79. Story of my life. Line 79. Oh, look, I can't spell. Not fin in map, find in map. Very unusual for typos to happen in the stream. Try it again. At least it didn't fail by the time we got here, right? All right, validation worked. That's a plus. There we go. And we'll go back here, go to CloudFormation. And it changed regions on us. We'll go Canada. And there's our stack. Should just have the single EC2 instance. Oh, look. Oh, look what I did. Oh, aha. Cut and paste. Cut and paste got us again. Back here. Whoops, back here. The dreaded cut and paste. Look what I did. It's got to be compute EC2. I think that's what we called it. Yeah, compute EC2. Try it again. Oh, while I'm waiting, shameless plug time. We started a podcast. The idea is once a week, Fridays, we will talk about interesting articles, you know, news releases, service updates, things like that, from the previous week. Let me see if I can find you something here. So you can get it on Spotify. There's Spotify. And then you can also get it on, for now, we've put it on Apple Podcasts as well. So there's a couple links if you wanted to check it out. Okay. We're one episode in. Oh, look at that. And while I'm self-promoting, it fails. Oh, I forgot. Yes, remember this is our default EBS key. So in here, if we go data protection, see this alias? This is the alias we want. So if we go KMS, we go to AWS Managed Keys, we want the EBS key here somewhere, this one, and we want the ARN for that, and we've got to put that, this needs to go, oh yeah, we were going to pass this in, right? So we're going to say KMS key ID is that, and then KMS, I made this name really long, didn't I? Here. Yeah. Did I refer to it properly down here? Yeah, I did. Okay. So we got to do this. I usually like to make these names the same. I find it just easier when you're trying to troubleshoot it later, so let's do that. Now, I just introduced an error here, which hopefully we won't see today. But KMS, like AMIs, are regional services. And in our little demo here, I said, oh, you could use this same template and deploy it in US East 1. Actually, not the case, because what would happen now is I only have a single key ID, right? So if I tried to deploy this in US East 1, sure, we have the AMI copied over there, but we don't have the proper KMS key ID in US East 1. So we would need, the way I'd immediately think about it is probably another map file or something like that to say, here are the key IDs that you want to use in each of your regions or something like that. Okay. All right, so that looks a little better. If we go back over to CloudFormation, should have another stack, and let's deploy it. Now, if I don't have any typos here, this usually goes pretty quickly. Famous last words. Okay, that looks pretty good. So if we go to EC2, there's our new EC2 instance coming from no launch template. Okay. And if we look at here, you've got your role info. If we go under storage, now we've got 2 drives. They're encrypted. Okay. Here's our root volume 8 gigs and our data volume 50 gigs. Okay. So that means we are done. And we get to our 4th and final task for the stream tonight. We want to deploy an EC2 instance using a launch template. Okay, so let's build that out. It's going to look very similar, just the way that we deploy it is a little different. So let's get rid of all these. Clean this up a bit. Actually, I'll copy this one. So we'll dump that here, and we'll say, yeah, we'll leave that the same. We're probably going to use most of these parameters. We're just going to use them in a slightly different way. So let's do this. We're going to call this LT, and our type definition, I've got to look it up here. Well, that's an obvious one. It's EC2 launch template. Okay. We'll say properties. Oh, let me share this and we'll just have a quick look at it. Dump this here. Brain is a little fried tonight. So if we go here, okay, here's our launch template. Looks pretty basic, right? The majority of the work happens in launch template data. And if we go into launch template data, this will look familiar. Okay, this is essentially the same thing we did in the EC2 definition. But now we're creating a launch template with it. So let's see if we can build this out. I might try just to copy it. Oh, I forgot something. Okay, let's fix it. I'll point it out when we get there. So what we're going to do is we're going to say launch template data. And then we're really going to try to cut some corners. We'll see if this is successful or not. We're going to grab this and we're going to go all the way down. I think we can take even subnet ID and everything. I think it's all the same. Security group IDs. There is no subnet ID, so we need to still provide the subnet ID when we launch it, which makes sense, right? So we're going to do this. We're going to go like that. We're going to copy this and we're going to dump it here. Let's see, spacing looks not too bad. The thing that I forgot was something that we did manually in the console. We set up our metadata, and we set metadata to version 2. If I go back and we look at that other machine, let's go check. We go back to Firefox. We go to our EC2 instances, and we go under, it's here somewhere. I never remember where it is. Details. Oh, look at that. It's required. That might be because we're using a newer version of an EC2 instance, like the T4Gs, using the ARM processors. So that's good. I would still hard code it. There's no reason why not to put it in your template. So I'll show you what I would normally do. Okay, so let me just find it here. Yeah, it's here. So I would do this: meta data options. So if my thinking is correct, I'd have to look in the documentation. We're getting it either because it's baked into our AMI, or because we're using a newer version of an AMI. And I don't recall off the top of my head why it's picking it up the way it is. But let's say you're not responsible for creating AMIs. Somebody else does that. And they don't put that feature in the AMI. They overlook it for some reason, and default encryption isn't default encryption, sorry, but they don't have metadata set up. So I would say it's probably a good idea to put this in your template. Can't hurt, right? And then that way you're going to ensure that going forward you've got metadata enabled at version 2. And setting this up is pretty basic. All we need to do is we need to say, there's just one thing. I think it's, yeah, here it is. It's just this HTTP tokens. And you know what? I'm going to show you something else. We're going to make this required. If I go back to here, and we go and look at, so this is the launch template data, right? And here is the metadata options. This is what we just set up. If we go look at EC2, the last time I actually looked through the whole list, I don't think, if you use EC2 instance, I don't even think metadata is here. Yeah, see, it's not. So then we're picking it up. I'm going to make an assumption that we're getting it set up because we have it in the AMI, in our custom AMI. If you're launching an EC2 instance through CloudFormation, it's not even an option here. You've got to get it through your launch template. Okay. I don't know if you can do it on the command line or not. To be honest, I've never launched an EC2 instance from the command line. To me, it would be absolutely insane to try to get all this in a CLI command. I can't spell words correctly. There's no way I'm gonna be able to type all of that in and get it right. Okay, let me just have a quick look, see what else is here. Do we need to add anything else? I don't think so. Yeah, I'm gonna take this as good. And then we've got one other thing we want to add. Tag specifications. Okay. And then we're going to say resource type. And there's a bunch of resource types that we can use here, but we're just going to hard code this for today because the launch template is associated with our EC2 instance, so that's fine. And then we're going to say tags. The rest of this will look the same. So we're going to grab this, go like that, and then we're going to say EC2 launch template just to be able to see the difference between them. Okay. So that's our launch template data. I think we've got everything that we need. The rest of the launch template is pretty basic. Let's shrink this down to make it a little easier. And we're going to say launch template name. You know where I'm going with this, right? Use intrinsic functions if you're building this out from scratch, or you could leave it blank. If you leave it blank, let me just check this one. If you leave it blank, it's not a required option. So if you were to not provide a launch template name, CloudFormation will generate one on your behalf. My personal preference is you don't hard code these names, But for today, again, just to make it easy to find, we're just going to say Twitch demo LT. Okay. So that's that. And then we have tag specifications again. And this, I don't know if I spelled that right. Yeah, I did. This is the tags to apply to the launch template itself. So we're going to say resource type is launch template, right? And then we'll do the same thing that we did before. We don't need the name because we set the name already. We'll do this. Whoops. And we actually need tags like that. And then we can just dump that in there. Now, did I do resource type down here? There's our launch template. Oh no, what did I do? Oh, I see what I'm doing. Yikes. Okay, here. I shrunk this down and I'm like, did I just... Yeah, okay, resource type. I'm like, did I just delete a whole bunch of stuff I needed? Okay, so we've got our launch template name, our tag specification. Is there anything else we need? There is a version description, a description for the first version of your launch template. Not required. I'm not going to worry about it. Okay, so we're going to leave all this. And then we're going to do this. We're going to get rid of all of this. This. And we'll just change its logical name. And I'm going to go down here and do this right away because I will definitely forget about this. Okay, so we'll do that. And then we need to specify our EC2 instance, how we want it to be launched using a launch template. If I can find it again, EC2 instance, there we go. And really all we're doing is we're shifting all of that configuration into the launch template definition up here. So now our EC2 instance template becomes quite easy. So we're going to say here launch template, and we need to then provide it with some info. We're going to say launch template ID. That is going to probably be a ref, an intrinsic function, but I'm not 100% sure, so we'll look that up. And then we need, one of the things with launch templates is they have versions. So if you modify your launch template config, you have version 1 and then version 2. So we need to refer to the version of the launch template that we want to use while we're launching our EC2 instance. Okay. And this we can pull as well from the launch template output. Okay, so we can do, where is this here? Give me a second. Did they give us an example of this part of the reference? I can't remember. I don't think they do. Yeah, they don't. Okay, hang on. I want to look at the outputs from launch template. Maybe it's in here where there's an example. I've seen this before. Okay, so the first thing is we need the launch template ID. Yeah, so that's just ref. So we can do this, ref LT. And like we normally do, I'll do this, depends on LT. Okay. And then the version, we need a get attribute intrinsic function. We're going to say LT dot, and we will say we want you to run the default version. Okay. So that's that. I think we still need a couple other things because we haven't defined where this EC2 instance is going to be launched. Like, we haven't given it a location, right? Did I maybe miss something? Here, I'll show you what I'm looking at so you're not wondering. I'm looking at, I went back to the launch template doc. this one here. Remember, under our launch template data, I just wanted to make sure that I didn't miss something about the subnet. I don't know. I want to say that I didn't. Security groups, text. No, I didn't. Now this is interesting. What is this? The maintenance option for your instance. The maintenance option to declare this. I don't even know what that is. Look, disables the automatic recovery of your instance or set its default. Always an opportunity to learn new stuff. So I think we're on the right path here. That means if we look at EC2 instance, right? Most all of this has shifted into our launch template, but I still need a subnet ID, like where is this going to be launched? So what we'll do is we're going to go back over here and we'll just do this subnet ID, and we'll borrow that from here. Whoops, not that. We'll borrow that from here, but I'm going to change it just ever so slightly. We're going to launch it in the other subnet. Okay. So now you see we've put all the bits and pieces in our launch template, and then our actual EC2 launch is quite easy. So now we go back here. We'll run this, and this is called launch template, and then we can go to our deploy script, and this time I'll make sure I change the name, right? Go here. We'll say EC2 LT. I don't know why I used LT everywhere and then the full name for this, but that should do the trick. Okay. Let's see what happens. Well, we made it through the validation phase. That's good, right? Success. I should change the runner config on this. Here's another to-do item. Change the runner config to run multiple jobs at once. I think we have this. It's just a small little EC2 instance that we're running this on for demos. And I think it could handle more concurrent jobs at once. But I never think about it until we use it once a week. Okay, here's our new launch template. And we should see two resources this time. The launch template itself and then the EC2 instance from the launch template. So let's execute that. Instance profile. Oh, cut and paste. I remember this. It looks slightly different, the configuration of the launch, of the instance profile. I should have remembered that. Let me get the actual setup here. Yeah, okay, so let me show you this. Let's delete this because this will hang us up later. All right, so we'll go here. And what we need to do is go here. And this changes just slightly, just enough to mess us up. Expects an object. And then here we can say, we can do this. That's all we needed to do. I don't really know why in the EC2 config it's just a string, and in here they want to want you to provide an object. I don't know what the difference is. Oh, sorry, I didn't switch my screen. Here, this is what I did. See this? I just moved our import statement onto a separate line. That's it. Oh, look. Even though our stack didn't do anything, I don't know why this happens when you kind of run into an early problem. It sometimes will take a bit of time to delete. I don't know why. Oh, okay, still working. While we're waiting, time is it 8:49? Ooh, Leafs are losing 2-0. What's going on in the World Series? Oh, it's 5-0 for Texas. Oof. Okay, there we go. So let's go back here. And just run this job again. 5-0 in the bottom of the second. If they win, they're up 3-1 going. Oh no, they'll play in Phoenix again. Let's try this one again. There we go. So there's our launch template, and here's our EC2 instance coming to life. Perfect. So if we go to our EC2 console and we go to launch templates, oh look, I really got to fix my cleanup script. Maybe that's what we should do one time, just to change it up. We should work on some Python scripting and just create a series of scripts to clean up after a class. That would be handy, actually. I kind of work on it in dribs and drabs. So here's our launch template, right? And you can see in here, we've got all of our instance details, our AMI, their size, the security groups. Here's our storage volumes, tags for the resource itself, no additional network interfaces required, so we just get the default one, any additional details, and we should have in here, if I did it right, where's my metadata? There's metadata transport. Metadata. Oh, right here. Metadata version. They spread it out, version 2. So I hard-coded that into our template. Yeah, Kevin, you're right. It has been a fun World Series to watch. It's been a fun playoff in general. Right? There's been a lot of really great games, but the World Series has been really good. What was yesterday? Yesterday was 3-0? Oh, 3-1 yesterday. Yeah. Texas is a good team. All right, so that's our launch template. And then if we go to our instance, refresh, there it is, right? So there's our no launch template, and there's our launch template. And the only difference between these is the fact that one's in our one AZ and the other's in the other AZ, because we just changed the subnet IDs to test it out. And if we say connect, here's our machine. Right, and we're on the internet. You know, one other thing we could check here just before we wrap up, we'll go to CloudWatch. We'll go back to logs. Log groups. We should have the OS log now, right? Here it is. And multiple streams. one stream for each of the EC2 instances that we've launched. So that's good. And then if we go to metrics, there it is. This is what I was expecting to see before, the CW agent. This is the CloudWatch agent. And then if we drill into this, we can see now our memory usage, which we wouldn't have without the agent installed. Okay, so we can see we're really using a ton of our memory. But then we've also got, whoops, CloudWatch agent. I always forget what tab it's under. Here's mem used, just in a different view, right? So there's our mem used again. If we flip back to here, there's disk IO. One of them is logical disk. That's more. Oh, here it is. This is it. So see disk used percentage now, right? So we could just filter here, sort this. I could say disk used percentage. There we go. Right. This is all nice data to have. Okay. So there you go, folks. If we flip back here to our little checklist for the day, we created a custom AMI, we set up that instance profile, and we deployed an EC2 instance through CloudFormation, one with a launch template, the other without, and then we just, oops, wrong way, right? We talked at the very beginning of the stream about machine images as the starting point for your EC2 instances, regional services, sources of those images. So that is kind of what I wanted to cover for the week. It's about 2 hours. So as always, thanks for hanging out with us. We'll be back on Friday this week. The podcast, we're going to stream it live and then release the recording on the Monday after the weekend. So we'll be back on Friday at 1 p.m. Eastern if you want to hang out with us and have a look at some interesting AWS news articles from the week, cloud articles from the week. Otherwise, enjoy the rest of your week, folks. And as always, thanks for hanging out with me for a couple hours. I appreciate it, and enjoy the rest of your evening. Bye for now.